Any questions in the room?
My question was for Pablo Rivas. Okay, I see. How can you be sure that the features you are learning are not biased towards something like I'm posting something at some neighborhood or some city, or I'm mentioning some place, so it could be misleading?
I'm biased. I'm not sure. I think you're confusing the motivation of my unbiasedness of the model, but yes, it will be biased if all the pictures are from a city and it's learning those unbiased representations. It will be biased to us. But the unbiased on my motivation, it's unbiased towards specific races of humans who are being trafficked, or also unbiased with respect to labels. For example, if I have a ResNet, the inductive bias will be of the model would be created to the labels that the model was pre-trained on. So I don't want to feed those yet, because there will be aligned with text, and then that will be the inductive bias of the model to detect the illegal activity. But I agree that the model by itself will be biased towards whatever the data set
And
is.
so if that is not in your scope now, do you plan to cover something like that? Because I'm wondering if this is something you plan to work with some agencies, like I think you mentioned police. Maybe the model is checking how the buildings in the background of the picture look like, to just say, oh, this is probably trafficking.
Yeah, that's a great point. Yeah, I think we're, if I may comment on that a little bit, the law enforcement and the human trafficking agencies we're working with say that usually what the indicators, or the highest indicators of human trafficking, or predictors, features, are things that are not in the picture.
Okay.
For example, if a person is not showing the face, that is a red flag for human trafficking, or a specific tattoo that it's a branding of a human being, or a specific car in the case of stolen parts. That is also things that are there or missing, and not particularly like a building or things like that. And so I think it is important that if you want to collaborate, or if you have more information to provide, I'll be happy to talk more offline.
Okay,
yeah.
Thank you.
Hi, this question is for Lucia. 1 month ago, I had the chance to go to Azure Museum, and I got the picture complete, so I was there complete. Was that your work, or do you have any insight of comparison between the image I already saw and what you already published?
Yeah, that's a very good question. Thank you for your question. Many people have worked on restoring print gallery, Azure's print gallery, what you see on the center. That restoration that we had currently is the SOTA, the state-of-the-art, that was made 20 years ago. That restoration, we compare it in the paper, and we explain the differences. Basically, the main difference between previous restorations of print gallery is that we have used in-painting methods. So for in-painting, you only restore the damaged part of an image or of a painting. And before that, they had to restore everything. So if you see the current restoration that it is, for example, on the Ecce Homo, that she had to repaint everything, and the restoration of print gallery, they had to rebuild everything on print gallery. Well, we only touch the part that it's damaged, and everything else is original. That's the difference between the restoration that was made, or the completion that was made 20 years ago, that it's everything rebuilt, with our restoration that it's only working on specific parts. Thank you.
And in particular for the Escher
Yes.
work, because it was like a center circle, and the restoration I saw was incredibly amazing because it followed up the topology of the art. So, have you ever compared your work against that particular restoration?
Yes, we also follow the mathematical structure behind print gallery. Everyone who works on print gallery, they do the same. You unfold it back because the painting is so twisted that for some computer vision algorithm is you would have to learn the rotation, number one, and then learn to inpaint. That would be end to end. So what we do is we put everything back to straight, we inpaint, and then we warp it back. Everyone, more or less, in print gallery does the same thing. So that's the topology of the artwork. So the comparison between our restoration and the restoration that was made 20 years ago, it's basically on how much of print gallery you have touched. So they have rebuilt all of print gallery. They hire a painter, and the painter redid everything from scratch. So if you remember the restoration, it looks a little bit of made by hand, like a cartoon. And our restoration, it only touches the parts that were in the circle. And the rest of print gallery is the original one. So that's a little bit the difference. When you have in painting, you can mask only the regions that needs to be restored.
And in terms of architecture, because back to Escher, that's hard to complete because of the mathematics behind that. Back to turning the picture. So what kind of relationship you have between the problem and the kind of learning machine you designed, because it's not straightforward. So you need to code it, and you need to preserve the movement. So what kind of differences in your architecture that particular problem arose?
Yes, we are planning to have only a paper on print gallery, because that is actually a challenge. The challenge in print gallery, what you saw, is exactly the mathematical structure. And for that, the best thing is if you have trained your model in images that are twisted, your model will learn to twist an image. If your model has been trained, for example, typical GANs, if you have trained your GANs on data sets which don't have twisted images, your GAN will have to learn first, what do you mean by twisting and rotating, and then to produce content. So one thing you can do is convert everything that is similar to what they do with bird's eye in self-driving cars. When you have this bird's eye view, you turn everything into Euclidean plane or canonical form, so everything looks straight, and then you work with the image, and then you do the deformation back, so you will turn back to the plane where the image is. So that's what we did in print gallery. Thank you.
Yes, I have a question for Juan Miguel. Could you expand a little bit more on how the filters work? Are these like thresholds on the features of the data, or are you comparing to a distribution?
Yes. Yes. We first trained a deep learning model that can predict me if this is an encoded value I expect to see. So you know the values. Let's say, for example, the cities of the United States, you know the values, so you know the encoded values. And then what you do is you train using, you train the model saying that these are the encoded values and this has the value of 1. So if the prediction is near to 1, it means it's an encoded value I expect to see. But if it's near to 0, that it means a noisy observation, then I discard it. So the threshold you decided, it is a parameter. So the higher the threshold, the higher you are being more exigent to the model. I don't know if that answers your question.
But then you do need access to some public data to pre-train this filter, or how are you training that filter?
You train the filter with the values. So you pass, like, I don't know, Baltimore, and there's an current value. You pass the value, you only do what time. But what happens is that user values, one people can be in Baltimore, and other people can be in New York, and 2 other people can have in New York, and when we try to estimate is the count. So when we pass the values to the server, the filter says this is an encoded value, similar to the one I expect to see, or it is not. I don't know if that answers your question.
Yeah, maybe I'll ask you a little bit to clarify. But
Okay.
thank you.
Thank you.
All right, do we have more questions?
Hi. Yeah, it's question also for Miguel. So, without filtering, I guess you could do something like bias correction on the output of local differential privacy to try to estimate, I guess, count in this case. Did you try that instead of having to do the filtering step just to see what happens?
Yeah, as I understand, of course, in the estimation process there is a cleaning of the noise, but what happens is that normally you have users that have highly noisy observations, and when you try to, when they are in the server, you can go back. So this means that you have highly noisy in the server, and when you try to use the estimation process, like maybe a Bayesian estimation, so you have that noise. So what this the filter is, before adding this value, you discard it. Of course, you can count the value. Let's say I know that I see a new value, and then I do some processing techniques that can help me to improve this estimation.
Thanks.
Do we have more questions? Virtual? All right, so this concludes the first part of the morning session.